What is up, ladies and gentlefish? Today we will be going over chapter 6, and in chapter 6 I will be reviewing how to calculate wavelength given the frequency. So if you're ready, I'm ready. Let's begin. So here I have come up with another example problem. The problem reads, calculate the wavelength of a radio wave traveling at a speed of 36 meters per second at a frequency of 10 hertz. Much like my previous two videos, the steps have pretty much remained the same, except for I've decided to eliminate the fourth step, which is not converting, but rounding to significant figures, because like I said in my chapter 5 video, you guys should already know how to do it, so it shouldn't really be put into the videos, because it's just something very, like, everybody should know by now. But anyway, let's get on with the steps. So much like my videos for chapter 4 and chapter 5, the steps are to identify the info needed for the problem. Step 2 would be to set up the equation. And then step 3 would just to be plug in and solve. So like always, I will be going over step by step on how to solve this particular problem. So step 1 is again to identify the info needed for the problem. So referring back to the problem, we know that the frequency is 10 hertz and the velocity is 36 meters per second, but what we don't know is lambda, which is denoted by this fancy looking upside down y. And then step 2 would be set up the equation. So the equation would be lambda is equal to velocity over frequency. So why I do step 1, which is to identify the problem, is to so that when you not the problem, but what is needed. So is that when you get to step 3, you already know what you need to plug in, so it becomes so much easier. So now that you know what the frequency and the velocity is, you can plug those into the equation, and it would be lambda is equal to 36 meters per second over 10 hertz. And then the second part of this step is to solve it. So then after you have done the calculations, or just by looking at it, you can see that the answer would be 3.6 meters. So just for fun, let's do another problem, but instead of calculating the wavelength, let's calculate the frequency. So for this problem, I have calculate the frequency of a wave with the wavelength of 45 meters that has a speed of 24 meters per second. So for this problem, everything pretty much remains the same, except for there is a slight change, and that change is very small, but it will make a difference between you getting the answer right and the answer wrong. So for this problem, all you would need to do is just pull a partial Chinese fire drill and just switch the frequency and the lambda. So you would have it would be frequency equals velocity over lambda, and then so after you plug in all your values, the problem would read frequency is equal to 24 meters per second over 45 meters. And then once you do all the math that's involved, which is just simple division, your answer would be the frequency is 0.53 hertz. That is it for this video on chapter 6, guys. I hope you really enjoyed it. I had fun, but I had more fun teaching you guys. So with that being said, I will see you in the next videos for chapter 7, 8, and 9, and have a great day.